Today we're talking about the different types of reactions that can happen to hydrocarbons. So the most common one of these and the most well known is combustion, which we have dealt with for quite a long time. We do distinguish between a couple different types of combustion though. So the combustion you are most familiar with is complete combustion. This is when a hydrocarbon reacts with an excess of oxygen to produce just carbon dioxide and water vapor. However, there is also another type of combustion reaction known as incomplete combustion. And incomplete combustion occurs when not enough oxygen is present. This is one of the reasons that you'll see smoke coming out of fires. What smoke actually means is that the fire's not getting enough oxygen to fuel it, so some of the carbon, instead of being converted into carbon dioxide, is just being converted into soot. It's just breaking the hydrogens off and it's floating away as these tiny solid particles of carbon. Or another possible and much more dangerous byproduct of incomplete combustion is carbon monoxide, which is of course both odorless and toxic. So that ash and carbon monoxide get produced when there's not enough oxygen present. We can't actually predict exactly what proportion will be because there's too many dependent factors. How much oxygen, temperature, pressure, all of these play a role in determining the amount of carbon monoxide, carbon dioxide, and soot produced in incomplete combustion. And you can also have fluid dynamics with the airflow playing a role in that as well. So you won't ever have to balance one of those because you can't. But you do need to be aware that incomplete combustion is a thing, and it just means there's not enough oxygen. Another common reaction we see is an addition reaction. Addition reactions are pretty straightforward. It just means that you are adding something in. And the easiest time to add something in to a hydrocarbon is if a double or triple bond is present. So addition reactions specifically target alkenes and alkynes. A binary compound, so something like chlorine or hydrochloric acid, can react with the multiple bond, and that opens it up, breaking it down into a single bond, and then breaking apart the binary compound to bind on to the two carbons. Important thing with addition reactions is that the two substituents, the two things being added in, have to go on separate carbons. They can't both go on the same one. So if you see something like 1,1-dichloroethane, that cannot be produced by an addition reaction because that chemical can only be produced by getting the chlorines onto the same carbon, which addition reactions can't do. It has to add them on to separate carbons. Another important thing to note is that while I do say binary compounds, because that's the vast majority of things that react here, there are such things as addition polymerizations, which we'll talk about in a later video, which react larger compounds, and you can also react water in addition reactions. And when you react water in addition reactions, instead of producing a halogenated hydrocarbon or hydrogenating the hydrocarbon, which we'll get to in a second, you produce an alcohol instead. Now, a hydrogenation reaction is a very specific type of addition reaction, and as you might guess from its name, hydrogenation involves the addition of hydrogen. So the extra bond gets broken, turned into a single bond, and then you add the hydrogens onto each end, and this is how we turn alkenes and alkynes into alkanes. The opposite of an addition reaction is an elimination reaction. This is where you are pulling something out of a single bond from two different carbons to create a binary compound as well as a alkane or alkyne, or alkene or alkyne. So depending on what's getting eliminated here, you could have a couple of different products. If you're just eliminating two hydrogens, then you'll produce hydrogen gas. If you are eliminating a hydroxyl group, you'll produce water. And if you are eliminating a halogenated hydrocarbon, most likely you are going to produce an acid, hydrochloric, hydrofluoric, hydroiodic, or hydrobromic acid. It is possible to produce chlorine or bromine in their elemental states if you have a hydrocarbon that is halogenated on both the carbons that you're attacking, but it's not guaranteed. Another type of reaction that we'll deal with is a substitution reaction. So a substitution reaction swaps a hydrogen for another atom. So often this is used to create halogenated hydrocarbons, but this is not from alkenes or alkynes. We produce halogenated hydrocarbons here from alkanes. And again, we can do this with water to produce an alcohol. The important thing with this one is that you start with a single bond and you end with a single bond. There's no double bonds or triple bonds involved in substitution, because if there's a double or a triple bond, you will instead get an addition reaction. And finally, last reaction we should know about, we've already talked about, esterification. Esterification reactions are reactions between alcohols and organic acids. And this is a special type of condensation reaction because it produces water. And of course, condensation reactions are also a form of elimination reaction. But this elimination reaction is not within the molecule, so it doesn't create a double bond. Instead, it's between two molecules, pulling a hydroxyl group off of one of them and a hydrogen group off of the other, which leaves us with the oxygen bridge in its place that creates our esters.